Hello, welcome back to Algebra. In this lesson, we're going to conquer the very, very important topic called slope-intercept equation of a line. So this is part one of a couple of lessons. So in the last few sections, we've said that we can write lines in what we call standard form. But then I mentioned way in the beginning that, hey, there's more than one way to write the equation of a line. We already talked about standard form. We found the points on the line using standard form, and we draw, the line through those points, and we know that they form lines. But it turns out that there's another version of that equation that's also an equation for a line that's actually even easier to graph. So think of this lesson as actually a way to save you time because this actually makes it even easier to graph lines. So we're going to talk about the slope-intercept form of a line, and you'll understand why as we jump into it. So we recall that we can talk about standard form of the equation of a line, which we've already discussed many, many times, but just to refresh your memory, that's ax plus by is equal to c. So a, b, and c are numbers, any number you want. So an example of that, just to refresh your memory, an example of this guy would be, for instance, negative 4x plus 2y is equal to 12. So this is just, I made up some numbers. It doesn't matter what they are. But here's the thing. This is an equation of a line. You know it is because it's in the correct form. However, it's really difficult to look at this and know what the line is going to look like that. You can't really look at that and know, is it going to go that way? Is it going to go that way? It's a little hard. And we already talked about how to find a couple of points on the line. We know how to graph it. We know how we can make up anything we want for x, and we'll find the value of y. And then we can plot those points and draw a line. Of course, we know that. But it sure would be nice if I could look at an equation of a line and know right away roughly what it's going to look like without even plotting anything. In other words, if I were to know, is the line going to slant this way, or this way, or this way, or this way, and roughly where it's going to be. And then, of course, I can plot it, but it would be nice if I could actually just look at it and know that. And there is a way to do that. That's mostly the point of this lesson. Now, in order to get there, let's take this just an example, the second equation. Let's solve this for y. Y is in there. So I'm going to get rid of the 4x by moving it over. So I'm going to add 4x. So I'm going to end up with 2y is equal to, when I add 4x, what I'm going to get on the right-hand side is 4x plus 12. I just add 4x to this side, killing it, add 4x to this side, and put it in the front. So here I have 2y is equal to that stuff. Now I want to solve for y. So how do I do that? Y is going to be equal to 4x plus 12 divided by the 2, which is out in front. So that's just solving for y. But I think I mentioned this in a few lessons before. When you have an expression on the top joined with a plus or minus divided by something, I can also write this as 4x over 2 plus 12 over 2. Because what's happening here is I have a first term divided by the 2 and a second term divided by the 2, and I know that I can break them apart because if you were to go this direction and go backwards, like if I just cover all this up and said, hey, what does this equal? You would try to add the fractions, right? You'd say, well, there's a common denominator, so I need to have a common denominator of 2, and then I'm just going to add the numerators, which is what I've done here. So breaking things apart is exactly the same as going and adding fractions going this way, so that should convince you that this is legal, right? And so what you end up getting for y is what? Dividing the 4 by the 2 gives you 2x. Dividing the 12 by 2 gives you 6. So this is what we call the slope-intercept form of the equation of a line. And believe it or not, all we did was start with the standard form and solve for y. That's it. And when we do that, we get the slope-intercept form. And it actually makes it much, much easier to graph this, to graph lines using this version of it, okay? And you'll see why as we go along. So this is called the slope-intercept form of the equation of a line. I'm not going to write that whole thing out. The slope-intercept form. And in general, the slope-intercept form is the following. Y equals mx plus b. Notice right away that it matches up exactly with what we have here. You have something, in this particular case, b was equal to 6. In this particular case, m was equal to 2. Now, what do you think m and b are? Well, I bet you can make a pretty good guess what m is. M, this is actually the slope of the line. The same slope that we calculated from before, y2 minus y1 over x2 minus x1. The same exact slope. Remember, we were doing all kinds of slopes. Sometimes the slope was 1/2, sometimes the slope was -3, or whatever. This value here becomes the slope of the line, or is the slope of the line for this equation. And this guy is what we call the y-intercept of the line. So usually you'll see this in a textbook as something called the slope-intercept form, or you might see it as just y equals mx plus b form. It's very, very common just to call it mx plus b, and is probably one of the most important equations in all of algebra. And I don't actually mean to exaggerate that. I'm actually quite serious, because graphing lines in algebra is one of the most important things. I already mentioned that we can solve lots of equations in real life with lines. And what I'm telling you here is that we have a standard form, which we know how to graph by finding points on the line, and this form of the line makes it, is exactly the same thing, because all we did was start with this and we solve for y. But the reason we have another equation here is not just because we love equations, it's because using this form of the line actually is really easy to graph it. Easier than it is to graph this one. All right, so let's look at a little bit why that's the case. Okay. What we're saying is that if I give you an equation in mx plus b form, all it means is y is on one side by itself, and then I have something in front of the x. Whatever is in front of the x, whatever number is here, is automatically known to be the slope. I don't have to calculate the slope with y2 minus y1, x2 minus x1, because it's given to me in the equation of the line. It is actually the slope. And then this guy here is called the y-intercept, which is where the line crosses the y-axis. So here's the y-axis here. If you have a line, somewhere it's going to cross this axis. Maybe down here, maybe up here. Whatever the line is, it will cross somewhere, and the location of that crossing is given in the equation itself. So the reason we have slope-intercept form, and the reason why it's called slope-intercept form, is because without doing any math, I can immediately read the slope right off the equation, and I can immediately read the y-intercept off of the equation, and I can actually graph the equation just by knowing those things. So if I give you the slope-intercept form, I don't have to do anything. I can just graph it, and we're going to get a lot of practice with that today. All right, so for this particular case that we talked about as our little example, 2x plus 6, y was equal to 2x plus 6, right? What this really means is what? Whatever number is in front of the x is the slope of the line. We already said that's m is equal to 2, and b is equal to 6. Now, when we say b is equal to 6, it means that the y-intercept in this case is equal to 0, 6. Because the y-intercept is where this line is going to cross the axis. It has to have an x-coordinate of 0 because that's what an intercept is. It means there's no x value left or right. It's just crossing somewhere on the y-axis. So it has to be 0, for x, something for y. In this case, it's 6, so it's up here. It crosses at the 6th location up here. And we're going to get a lot of practice with that as we go along here. But the 2 for the slope means you have a rise over run of 2 over 1, rise over run. And the y-intercept means we know where this line crosses the axis. All right, so what we're going to do now is we're going to write down a few lines in slope-intercept form, and we're going to graph them. And then when we get to the very end of the lesson, I want to more carefully explain to you why this actually works. I mean, I can tell you that the slope comes right out of the equation and the y-intercept comes right out of the equation, but I'm just kind of telling you that. What I'm going to do at the very end of the lesson is I'm going to show you why it always is that way. But for now, before we get into the why, let's get into the how, because it is really one of the most important things. So for instance, if you have the equation y is equal to x plus 3. The very first thing you want to do is you want to identify what form of the line is this. It's not standard form, because standard form is something times x, ax plus by is equal to something. So I could move this stuff around and put it in standard form, but the way it sits is not in standard form right now. Slope-intercept form means I have a y on one side, something with an x, and some constant number on the other side of the equal sign. So if we have it in this form, I know right away that the y-intercept is 3, that's the number that's there, which means that this line crosses at 0, 3 is the y-intercept. So I actually know one point of the line right away. I know where that line crosses. I don't have to do any calculations. I know a single one point on the line just from that information. And then secondarily, I know that the slope is whatever is the number in front of the x. There's an invisible 1 here, right? Which, because you're going to have to use rise over run, so you need to write any of your whole numbers as 1 over 1 as a fraction, which means rise over run. And believe it or not, it's actually possible to plot this line just using that information. What you do is you say, well, I know one point on the line, 0, 3, and I go over here and I put that on my graph. 0, 3 is a point on the line. Now, up until this point, I know that the line goes through this point, but I really don't know which way it goes. I just know it goes through it. In order to draw the line, I need to look at my next piece of information, which is that the slope is 1, which means rise is 1 and run is 1. So rise over run, it's hard to say, rise over run, it's equal to 1, which means 1 unit up, 1 unit over. That's what it means. So what I'm going to do, I got to start from some point on the line, but I know one point on the line. It's right here. So I just go 1 unit up and 1 unit over for rise over run. I only need 2 points to form this line, so I could keep finding more points, but I don't have to. I only need 2. I will just put it right on top of here. And then all I have to do at that point is kind of go like this. I can go double arrow if I want to, and this is the equation of that line graphed. Now, of course, I can find additional points on the line because this is a point on the line. I can go 1 unit up from there and 1 unit over, rise over run, rise over run, rise over run. And I can find that every one of these little points are actually additionally on the line, but I don't need to draw them all because I only need 2 points to form a line. So when you're given an equation in a line in slope-intercept form, you don't really need to do any calculations at all. You don't need to calculate points. We needed to do that for standard form because we needed to have at least 2 points to draw the line, but the way standard form is set up, it is standard and you need to know it, but it's not really helpful to graph things. Once we have things in slope-intercept form, I literally can read 1 point off the line immediately and put a dot over there. And from that point, I just do rise over run. That gives me another point, and then I draw the line. Done. So let's get some practice with that by moving on. Let's say that I have the equation negative 3x plus y is equal to 4. And I said graph this equation. Now you might look at that and say, well, that's not in slope-intercept form. And you'd be right. What form is this, by the way? It is standard form, right? Because standard form is ax plus by is equal to c. And this is ax plus by is equal to c, of course. So if I were going to graph it using standard, just using the form I was given to me in, then I would have to go find 2 points. And I know how to do that. I've done it many, many times for you already. But I can now graph lines any way I want to. I didn't tell you how to graph it. I just told you that I needed to graph it. So let's move this 3x to the other side. So then y would be 3x plus 4. All I did was add 3x, making it go away, and I add 3x over here. So this is the equation. This is no longer in standard form. This is in slope-intercept form. Y is equal to mx plus b. And from reading directly off of this, I know that the slope is equal to 3, which also I know as a fraction is 3 over 1, which is rise over run. And I know that the y-intercept was equal to 4, which means that I know that 1 point on that line is 0, 4. I haven't really explained why this works, but I'm just telling you that when you have mx plus b, there's the slope, there's the y-intercept. So then you just go over to your graph and you put a point at 0, 4. All right, so we know our y-intercept is 0, 4, so we go over here and we just go and say 0 for x, 1, 2, 3, 4 for y. That's a point on the line. So the line can go anywhere through this point, but now I'm going to lock it down by using my slope. So from that point, up 3 units over 1 would be another point. 1, 2, 3 units up, 1 unit to the right would be another point, just like this. And then I'll just quickly draw a little line through there. Something like this. So obviously it's going to be steeper. And by the way, do you have any idea why it's steeper than the other line? Well, take a look at it. What is the slope for this line? The slope for this line is 3. What is the slope of this line? The slope of this line is 1. So we expect it to be a steeper slope. Both of these slopes are positive, so we expect both of these lines to be pointed in the lower left to upper right direction. I'll put it that way. which is exactly what we see. We see this line is steeper and this line is shallower, but we see them both basically pointed in the same direction. And then we can look at this equation. We know this one's going to cross at the 3 mark on the y-axis, which is right here, and this one's going to cross at the 4 point on the y-axis, which is right there. I have one more to do. We're going to go ahead and do that one, and then we're going to talk a little bit about why this actually works. Why is it the case, or why is it possible to read the slope right off the equation and read the y-intercept right off? I mean, it's something I think you should know why it actually works, so we're going to talk about that. So we're going to talk about why does this work? Because I don't like just telling you to remember things. I want to tell you why things work. So let's take as an example y is equal to 2x plus 6. What we're saying here is that you can read that the y-intercept is 6 straight off, and we can read that the slope is equal to 2 straight off of this equation. First, let's talk about the y-intercept. Why do we know that this line crosses at the 6th point on the axis, the y-intercept, just from reading it off of there like that? How do we know that? Because you have to go back to looking at what the definition of the y-intercept is. When a line crosses this axis up here, what it means is if it crosses right here, in fact, like this point right here, what it means is it's crossing at x is equal to 0. See, x goes this way positive and this way negative, but if you're crossing the line, x is 0 here. Any point that a line would cross on this line, this y-axis line here, whether it's here, whether it's here, whether it's here, whether it's here, if a line crosses anywhere, at any of these points, as long as you're crossing this y-axis, the x value is always 0. Because x positive goes this way, x negative goes this way. If you're crossing the line, x is 0. So if I take this guy and I substitute, if I want to find the y-intercept, I'm going to set x equal to 0, because if I set x is equal to 0, then I'm guaranteed to find the point that the line crosses the y-axis, because I've set the value of x equal to 0, which we know is where we cross the y-axis always. So if I put 0 in here, you'll have 2 times 0 plus 6, and this is 0, so then you found out that y is equal to 6. So from this exercise, if I just said, hey, what's the y-intercept? You'd say, okay, I'm going to stick x is equal to 0 in here, and I get y is equal to 6. So what I have found from all of this is that the point 0 for x and 6 for y is a solution. In other words, it's on the line. And anytime you have a point with the first value of x being 0 and then the second value, that is just the y value wherever you're going to fall on this axis. X equals 0, y equals 6 is right here. That's the y-intercept. So I'm going to put a dot there to signify that. Right above the 5 here is a number 6. So that's why you can read the y-intercept immediately off the graph. You don't have to think about it. Because anytime you want to find the y-intercept, all you're doing is setting x equal to 0. And because of the way the thing's written, if x is 0, then this term always disappears. And so then y is equal to whatever it is. So you don't have to do that math in your head all the time. All you have to do is realize if it's mx plus b, this thing right here is b. It's the y-intercept, always, because of what we just talked about. Now the next question I want to answer for you is, why is it that when you write mx plus b form, or slope-intercept form, why is it that the number in front here is always going to correspond to the slope of the line? That's a little bit weird, because we talked about standard form. I mean, you can look at standard form equation of the line all you want. A couple of examples are over here. It is not clear by looking at this standard form what the slope of that line is. That's why we use this other form more often than not, because we can read the slope immediately off of it. But when you read the standard form, it's really hard to figure out what the steepness of that line is. You can't really tell so easily. So why is it when we use the other form over there, we can read the slope off, but when we use this one, we can't really read the slope that well? Well, let's take a look to understand that a little bit more, and let's take a look at what this equation is really telling me. This equation is telling me that whatever value of x I stick in here, whatever it is, I'm going to calculate the corresponding y value. And also, the other thing is that whenever I put, what I'm claiming here is this is the slope, so rise over run, right? So another way to say is, this is basically the following. mx plus b, what I'm really saying is that it's like this. Since slope is rise over run, let me go ahead and substitute in for rise over run, right? This is what I'm calling the slope times x, let me go ahead and put this back in black. I want to emphasize that. Times x plus b, right? That's what I'm doing here. What this equation is really telling you, don't forget what rise over run is. It's telling you how many units up I move compared to how many units I'm moving over. Another way to say that is, it's kind of like miles per hour with driving. It's how many miles you go for every hour of driving, or kilometers per second, or whatever it is. Rise over run is how many units you go up in y for however many units you go over to the right for x. It's a comparison of those two things. How many units I go up compared to how many units I go over. The better way to say it is how many units I go up per how many units I go over to the right. So if I'm, in this case, the slope is 2. So let's just use some actual numbers instead of talking about this stuff here. So what we're saying is that y is equal to, the slope is 2, so what I'm going to write it as 2 over 1, x plus, and b in this case is 6, so I'm going to put it at 6. So what I'm saying here is that I know one point on the line is at 6. That's the y-intercept, 0, 6. But I also know that from any point on this line, I walk up 2 units for every 1 unit I walk to the right. For every 1 unit I walk to the right, okay? So it's a ratio of how far I go up compared to how far I go over for any point on this line, right? So then if I say, well, I'm gonna walk over to the right just 1 unit, right? Then I would say 2 over 1, that's how many I go up for compared to how many units I go to the right. Let's say I walk to the right only 1 unit. What do I get? So I'm going to have 2 over 1 times 1, so it's going to give you 2, plus 6. So you see what I've done here? I've taken my y-intercept of 6, and then this equation is telling me that if I walk 1 unit to the right, then I must walk 2 more units up, which means my final destination will be y is equal to 8, which means that if I actually put this value in, 1, 8 is going to be a secondary point on this line. 1, 8 is going to be a secondary point on this line because I put x is equal to 1 in, and I got y is equal to 8 out. So let's take a look at this and see if you can understand it. 1, 8 is what I'm saying here. 1 here, 1, 2, 3, 4, 5, 6, 7, 8 is a dot right here. Notice that I'm saying that this is another point on the line, but guess what? That's 2 units up, 1 unit over. It's exactly the same thing that I would get if I started from here and I go 2 units up and 1 unit over. So let me go ahead and connect the dots, and we'll summarize you know, what we kind of get out of that and why it's useful. So let me go ahead and first draw the line like this. The reason that this is the way it is because this equation is really telling you that whatever y-intercept you start with, in this case 6 on the y-axis, I have to go up 2 units for every unit I go to the right. So if I decide to go over 1 unit to the right, then it calculates how much additional I must go up in the y value because of the ratio of rise to run, all right? And I just add that number to whatever my y-intercept was. So this whole math here is doing exactly what we always say when I say, hey, start here and go up 2 units rise over run. Up 2 over 1, up 2 over 1, up 2 over 1, and you're always on the line. Because the rise over run, the value of the slope, is telling you how much more y you need to gain for every unit of x you move to the right. That's why you can walk in a stair-step fashion along the thing, because I just tell it how many units I'm going to run, and it calculates how much more of a rise I need, because slope is the ratio of rise to run. I hope that makes sense to you. That's why we can write it that way, because it's calculating a new value of y added to my y-intercept given the ratio of rise to run and how far over I have to move for whatever point you have. I can stick another point in here. I can put 10 here, and when I multiply it, it's going to calculate how many units up I have to move from this location, right? Because if I move 10 units to the right, then I must move 10 times 2 is 20 units up. And then you add that value to the y-intercept. So that's the basis of being able to pick any point on a line and then go rise over run, rise over run, rise over run, because that's what the equation is doing. It's calculating a new value of y given values of x that you put in. But even if none of that makes sense, the only thing I really care that you remember from this lesson, this is slope-intercept form. You can read the slope immediately off and put a dot on your graph, and you can go rise over run from that point to draw 2 points on your graph and draw a line. So make sure you can do that. Follow me on to the next lesson. We have some more equations of lines in slope-intercept form that we're going to solve to give you additional practice.